Okay, we're moving along through section 1.4, and we've covered factoring and the quadratic formula, and now we want to use the square root property to solve a quadratic equation. I'll state what the square root property is in just a minute, but I thought I would lead out with an example. And so the example is x squared is equal to 9. And so if we just think about this, of course this is a quadratic equation because it has exponent 2 on the variable. And so we're saying what number can you square to make 9? And I bet you would say that 3, it must be one of the answers. And then hopefully you would think of another answer. The other answer would be negative 3. So two different answers, positive or negative 3. And so how did you get that? You just take this 9 and take the square root because that's the opposite of this squaring on the other side. And so what the square root property says is that we can drop the square here on the left if we just take the square root of the other side, and if we're also real careful to have a plus or a minus. So a lot of students remember the square root on the first exam, but too many students forget the plus or minus in front of that. So be careful with that. And so let's go ahead and state the square root property in general. It just says that if x squared is equal to a, or some constant, then x must be equal to the positive or the negative square root of a. So that doesn't sound too bad. Let's go back to this first example, x squared equals 9. We've got our two solutions, 3 and negative 3, and the last thing we might do is list them out with the braces around them to show set notation. Okay, the next example is very similar, but it'll be a little bit different. So how should we start this? Well, if we're going to apply the square root property, we need the x squared alone on one side, and we need a constant over on the other side. So in the previous, with the previous methods, with factoring or the quadratic formula, you always wanted a 0 on the right, and now that's not what you want. Now you want the x squared alone on one side. And so the first step is going to be to subtract that 9 to the other side, and then we have x squared is equal to negative 9. And then I bet you can see where this is going. So now we have the form of the square root property, and we can go ahead and apply that property and say that x must be equal to square root of negative 9 with a plus or minus in front of it. And so we've talked about simplifying the square root of negative 9. That would be that the negative comes out as an I, and then the square root of 9 is 3. So we're going to get plus or minus 3i. And we could write that with the set notation. I have frequently invited you to check your answers to see that they really are correct. Maybe this is one time when we should actually do it together. So, and it won't take very long either. So let's just come out to the side here and let's just check, is it really true that 3i is a solution to this equation? And so we'll plug back into the original equation. Wherever we see x, we write 3i squared plus 9 is equal to 0. And then that's a question, and we just need to simplify this expression here on the left side of the equal sign. So what is 3i quantity squared? Well, we need to square the 3 to make 9, and we need to square the I to make I squared. And then do you remember what I squared is equal to? It's -1. And so -1 times 9 is -9, plus 9 makes 0. And so yes, it really did work. You could check the other answer, the -3i, and you could see that it would work as well. Okay, let's go on to another example. We have 3x squared plus 5 equals 10. If that equation looks familiar, I wrote it on the first video in this section, but I didn't actually solve it. So let's solve it now with the square root property. So remember, we wanted to isolate the x squared on one side, and so we can subtract 5 from both sides, and we'll have 3x squared is equal to 5, and then we can divide by 3 on both sides, and x squared is equal to 5/3. Now we're ready to apply the square root property. It says we can drop the square on the left if we just add in 2 things on the right. First a plus or minus, and then the square root of 5/3. So this is a good answer. I might even put a box around it. Now, we don't normally, depending on which textbook you look at, you don't normally leave your answer like this. Usually what you would be expected to do is to split up the square root, write the square root of the numerator separately from the square root of the denominator, and then rationalize the denominator. Which means get that square root out of the denominator. And so the way we do that is we just multiply by square root of 3 in the numerator and denominator. And then x is equal to plus or minus, in the numerator, root 5 times root 3 makes root 15. And in the denominator, root 3 over times root 3 is just 3. And so that would be a better way to write the answer. And then, of course, you could put it in set notation as well, like we've been doing on so many other problems. Okay, let's go on to this last example. I think I'd like to start just by rewriting the square root property. It says if x squared is equal to a, then x is equal to plus or minus the square root of a. And when we look at this problem, we don't have x alone getting squared. Now we have x minus 5 getting squared. And so you might be thinking that we need to do something to get rid of this minus 5. And the clever thing to realize is no, we don't. And in fact, what we can do is we can treat x minus 5 just like we treated x, just like we treat just like we treated x in the previous examples, or just like we treat x here in the formula. So when we look back at this formula here, at the rule, it doesn't really say x has to be squared. It just says that anything has to be squared because x can be anything. So x in this case is replaced by x minus 5, and that's fine. And so let's get on with this. What we can do is we can get rid of the square on the left. We can drop it away. What do we have left? X minus 5. If insert two things on the right. First a plus or minus, and then a square root. And then, of course, that goes over the value that we had on the right, which was 8. And so that's a great step to be able to take. That's a really important idea when we get to the next method called completing the square. Okay, so let's go ahead and finish this. If we want to solve for x, now we're going to add 5 to both sides. And so x is equal to, usually we write the 5 first and then the plus or minus square root of 8 afterward. And then there's one more thing to do, which is to remember to simplify the square root of 8. You could make a factor tree, or you could recognize that 8 is the same as 4 times 2. So the square root of 4 is 2, and then the square root of 2 just gets left behind. So here is our solution, and again, we could write it in set notation. Two solutions to this problem.